screen share that. So we're going to just run through how to do the most basic SolidWorks for the engines we're designing today. This is not what we're doing today. This is actually the regen engine itself. But eventually, in the next week or two, we're going to start getting to something that looks a little more like this with the nice nozzle curves and everything. But for today, what we're going to do is make a new part. So file new part, all right. And hope that SolidWorks doesn't crash, because Zoom and SolidWorks running at the same time doesn't make this too happy. Close the other one. First thing we're going to do is make a new sketch.
Real quick, which units? I'm going to assume we're using like meter, kilogram, second?
Yes. Yeah.
Okay. And then dimension standard, just ANSI?
Yep.
Cool.
Don't worry about it too much, because you can just type in whatever units you want,
Okay.
and it'll auto-convert. So for example, I usually leave mine in IPS, inch pound seconds, just because it's easier to tell what's going on. But I'm going to put all my units in meters. So very first thing we're going to do is literally just draw a line here. We're going to click on that, say infinite line.
In case anybody knows the answer, is there a way to have SolidWorks not be awful on a second monitor?
Nope.
Gotcha.
It just, if you have, well, you can have two monitors running, but if you have it stretched between, like if you have it running on both monitors at once, it doesn't have a good time.
Yes.
Yeah, so first thing is just make a infinitely long line and have for construction checked off. Exit sketch, that's done. Then we are going to go back, make a new sketch again. It's going to ask us what we want to do it on. I'm going to drop down here, say the front plane again. What we're going to do now is kind of just blindly sketch something that looks like what the engine will look like. Making sure it's kind of a closed body. Now this looks nothing like what the engine will actually look like yet, but the kind of shape is there. I'm going to go in, make this be horizontal. Everything else kind of auto-completed to be the right vertical or horizontal. The other things that we're going to do is, before I go to actually set the radius on anything with length, is I'm going to set the angle on the diverging section of the nozzle, which, as Jackson discussed last week, is going to be 15 degrees. So for this, I'm going to use the smart dimension and stretch it between the center line we drew on the other sketch and the diverging section line. Set that, just type in 15. It's going to screw up what this looks like right now, and that's fine. Then similarly for this section here, this angle can vary anywhere from 30 to 60 degrees away from the vertical. Actually, I'm going to define that one a little differently. Yep. Sometimes it's hard to delete dimensions that get drawn. But same thing, I'm just going to go from here to here and pull it this way. But yes, as I said, this can be anywhere from about 30 to 60, 65 degrees. Generally, making it smaller is more conservative, but then your engine's longer and heavier. So I'm just going to kind of arbitrarily split the difference and say 45. There's no great way to say what's best for this without doing a bunch of fluid simulations. So I would just, for what we're doing right now, I would just kind of pick a number and go with it. So, okay, we have our nozzle angles defined. Then the next big thing that we're going to do is actually input those radius numbers we pulled from CEA last week, which this is for the engine that Jackson and I designed. We're going to start from the top just so that SolidWorks stays a little happier. And then inlet radius. It's right here. Well, this would be what we calculated as the minimum, and here's our chosen. So I'm going to use this number, which is 0.2 meters. That's because this is straight. I can just define this as the kind of chamber. You can see that this is still in inches, which is bad, but I'm not going to change it right now. But instead, I can just type in 0.2 meters, and it will auto convert. Next, I'm going to use the chamber length here. I'm just going to copy this. And that can be given by this length right here. This is all done with the Smart Dimension tool. Paste that in, type in meters, hit enter. Next thing is going to be, I need to find the exit radius, which is right here. Same thing, copy that. Then I need to pull this to this point here rather than to a line. As you can see, that broke absolutely everything. What I'm going to do is leave Smart Dimension. I'm just going to pull this down until it straightens itself back out. All right. So you can kind of see that, like, the way these nozzles end up looking is your combustion chamber is kind of tiny, and then your nozzle is very large and long. The one thing I have not defined yet is the throat. And as a first thing, let me just do that real quick to this point. And I have that listed as this right here. Same thing, copy and paste that. There we go. So as of right now, when everything is actually defined, this will, all the lines at the edge of this will turn black. Right now, there's still things I can like pull around and move. So I'm just gonna, to make it be better defined, which you don't absolutely have to do, it's just kind of good practice. I'm just gonna set that throat, not vertical, horizontal with the kind of origin there. And I'm going to set this wall to be 2 inches thick. Why not? At the values. So that gives me kind of the outer cross section of this engine at the moment. Going to now exit sketch, save this to, not here. Save the file. Really should have done that before, but whatever. Now I'm going to go to features and hit Revolve Boss Base. Now it's going to select this region in selected contours and select the axis of revolution. We're going to select the one that we made in that first sketch, this infinitely long line. And now it's going to just make a nice circle here. I'm going to go to a cross-section view. And there we go. So that's the basics of what this engine looks like right now. Obviously, we don't actually want these to be like super sharp turns. It's not great for the flow. So we're going to go back in here. No, sorry, wrong sketch. I'm going to go back into this one. And we're actually going to delete this. What we're going to do instead is draw an arc. I'm going to put the center just kind of in an arbitrary spot over here. Stick it to this, again, in an arbitrary spot. Sometimes you gotta like play with this a little bit to get this to cooperate. And then just stick this out here somewhere. I'm gonna go in and add relations to each of these. So selected both of them, and I'm gonna say a tangent relation. So it's gonna force this arc to be tangent here. And then I'm going to select the other part of the nozzle and do the same thing. So now this is completely forced to be tangent.
This is gonna be a really stupid question because I followed you so far, but how do you pan?
Oh, sorry. Oh, yeah, you definitely want to have a mouse for this.
Oh, a touchpad's not great. Okay,
Touchpad is very not great
cool.
because you want to hold down the mouse's middle button,
It's
and
the
that'll
middle
let you
click, yeah.
rotate.
Damn.
And then
Okay.
scroll in and out is to zoom.
Yeah, that makes sense. Okay, I'll find a mouse.
You can do it with touchpad. Like if you do it with touchpad, you need to right click and then you can, sorry, this isn't a section view. I should turn off section view for this. You can right click.
Yeah, I
and,
found it, and then select what you want.
Yeah, it's just not a great time because you got to keep switching.
Right. But
Like-
I found it. Thank you.
Yeah, so you can do it there. Right. So then you have this arc here. And what we're going to do is draw another line just kind of off this at an arbitrary spot. We're also going to say for construction for infinite length and vertical. And it's snapped to create a tangent mate there, I think. Oh, I did it. Sorry. Well, yeah. So it made a tangent mate for itself. If it hadn't, we would have done this and said be tangent. This kind of gives you the location of closest approach to the center, which is also the same as your throat area. So now what we're going to do is do that same dimensioning and copy in the throat area. I copied. Now this kind of broke everything. That's not completely unexpected. This will happen. See why you're angry. Tangents. Why are you angry? Okay, I don't know why it's angry, but we're just going to say trim, and we're going to chop off these two sections, or three sections, and now it should be happy again. Yep. So now we kind of have this nice curve going. Fortunately, now it's just angry with this because it managed to draw itself a line here. Stuff like this happens sometimes in SolidWorks. It's just stupid. And we're just going to select those 2 points and say merge, and it's going to break. Okay. So let's keep that, and then merge those two that way. Now it's happy again. Oh, never mind. I see what happened. this can move, which should not be possible. So we just need to set those 2 points to merge. No. All right. Why SolidWorks? Okay, there we go. Now tapping. Something's still not completely defined, but I don't really care right now because it still looks right. And we have our exit radius, we have our inlet radius, and we have our throat radius here. You can usually tell what's not defined by pulling stuff around like this. And as you can see, this is changing the converging area, but it's not changing the exit area stuff. And this is where the it doesn't matter a ton what the converging area looks like. It kind of comes back in. That might be it. Yeah, there we go. So I just kind of put that there to define where it is relative to the origin. Doesn't matter really. Yeah, that's good enough for this right now. We're going to exit sketch. And we're going to look at this again. So now we have a nice slope through the throat, which looks a bit better. Now what we're going to do is add a curve here. Generally doing what I did in the throat is not a great idea for adding curves because it's hard to change later. You're much better off adding a fillet feature outside of the sketch like this. This doesn't matter a ton what the radius is, so I'm just going to kind of arbitrarily say a 2-inch radius fillet on that curve. Let's check that off. And yeah, now we have a nice curve there too. So this kind of gives you the basic geometry of the engine, where you have your chamber here, your nozzle throat, and then your nozzle exit. What we're going to do next week is take this and then convert it to actually the kind of swoopy curve that you saw on the regen engine when I pulled that cat up. Any questions on that?
Did you say it would be a bad idea to try and use fillets on the throat area for now?
Yes, so the reason I didn't do the fillet in here is because it's hard to set this dimension accurately if you do. Because if you leave it as a sharp corner, then fillet away the corner, then you lose what the actual distance here is.
Okay, got it. Thank you.
Yep. Generally doing this is a pain because now to change anything here, it'll break whatever I do, versus for the fillet I put on here, it'll just kind of auto update and be happy. Okay, that's what it is. Yeah, this is the dimension I forgot to define here. This, we'll get to this more next week, but this generally should be about, this should be about 3 times your throat area, which I still have copied. And there we go, now it's happy. We're gonna exit that, and yeah. Questions, comments, concerns?
Is Thursday's meeting going to be dedicated to actually doing it for real this time?
Basically, Thursday's meeting will be getting through the CEA, pulling the information from the CEA and getting everyone to this step.
Oh, gotcha. Okay. And then like
Then-
next week we'll be doing the.
Yeah,
Cool.
the map involved in making the actual curve is it's decently complicated to go over why it needs to be that way.
Yeah, you kind of lost me in the middle there. Not gonna lie.
Yeah. Well, so the reason that like this is a very basic nozzle. This is basically just what people have found works if you just keep it as like a cone. Next week we'll be making the parabola version of this. So that'll be kind of involved. So that'll be all of next week. Right now, we just
Gotcha.
want to get everyone up to the same page of having this and being able to actually look at their engine. Okay, I'm going to stop recording then.